Alright, so we are at Booklet B of your science practice paper, question 29. Diagram 1 shows the direction of blood flow in some parts of the human body. So you have got X going towards Y and then going to all parts of the body. So if you recall the first chapter of science, you will always start off with the respiratory system. So this is going to be the lungs. And then the lungs is going to pump blood that's rich in oxygen to your heart. And your heart is going to pump all those blood rich in oxygen to all parts of the body. Alright, so identify organ X. That's easy. It's going to be the lungs. Name one substance that's higher in C than in D. Alright, so let's look at the direction. The direction of C is such that you have something going from the heart to all parts of the body. Alright, and that's something that's high in amount, high in a particular gas. And that has got to be, of course, the oxygen. Because it's where oxygen is being pumped into all parts of the body before they are being used up. Okay, so which arrow will represent the blood vessels that carry blood that is rich in carbon dioxide? That means most part has been used already. They are all going to be pumped up back to the lungs, and that will be because they are asking for more than one arrow. So the arrows that will represent those that are rich in carbon dioxide are those that are going back to the heart, are those that are going back to the lungs itself. Okay, so number B is definitely 1. That's 1 going back to the lungs, and the other one would be D, also going back. Alright, going back to the heart, going back to the lungs, all to be respired, all to be exhaled out. So the two answers would be B and D. Question number 2, the next one. Diagram 2 shows how the three human body systems work together. You have PQRS representing the blood vessels. Now, comparing diagram 1 and 2, which blood vessel in diagram 1 is best represented by Q in diagram 2? So we're interested in this part here. Okay, we're interested in Q. So from circulatory system going back to respiratory system, alright, would mean that there's a lot of carbon dioxide and very little oxygen because it's going back to the respiratory system, ready to be exhaled out. So which blood vessel, it can be more than one again, would represent the carbon dioxide and oxygen going towards the respiratory system? And it will be over here. You look at diagram 1, it will be the one that goes to the respiratory system that's rich in carbon dioxide. So the arrow will be B in this case. It's quite a straightforward question. Okay, alright, so let's move on to the next question, question 30. The arrow shows the flow of blood in a fish. So like I said, fish respiratory system is a very important system. Fill in the letters A, B, and C to show the comparison of the amount of oxygen. Alright, so oxygen, the most highest amount will be the one that's fresh, just inhaled in. And so that goes to starting from the gills, transferring to the body, right? So A must be the highest in oxygen. Okay, now the one that has just finished its round going back to the gills to be exhaled out would be B, because it has traveled one full round already. The oxygen has been mostly used up by the fish, so B must be the lowest in oxygen. So there you have the answers B, and the highest will be A. What is in the middle will be C. B, C, A. Alright, question next. Diagram shows a fish tank containing well-fed fish. So it's already well-fed. It has all the food it needs. After some time, the fishes were found to be swimming near the surface of the water. So those who catch fishes at home, sometimes you realize that happens as well. So a few possible answers I will accept. Now the first possible answers, if you tell me that isn't enough dissolved oxygen in the water, that is already the keyword. Okay, remember the so part. So what happens? So the fishes had to come up to inhale more oxygen. So that is one possible reason. Okay, now some of you may have a different answer. Instead of saying about the water not having dissolved oxygen, you mentioned they are just coming up because they need to get oxygen. That's also okay. Alright, so this is another possible answer, but the better answer would actually be number 1. Okay, so no dissolved oxygen, that's why the fishes had to come up to breathe in more. Now I'm suggesting that some of the important keywords must be in. Dissolved oxygen is 1. Alright, that's about it actually. So that's for question number B. Okay, question 31. Study the circuit diagram below. Connect the batteries and the bulb to make the circuit like above. Alright, so you have got 2 batteries, which is why there's 2 batteries. There are 2 batteries in the circuit diagram. So remember, it must have one wire that's connecting the tip, one that connects the metal casing. Alright, so we are ready to go. Now the plus is to be connected to the negative, and one goes out this way, so you can connect it to either one of the wire. Then the minus would be towards another part of the bulb. Alright, so can you check that you have a positive going to a negative? Some of you may have a negative going to a positive, that's also okay. And make sure that the 2 parts of the wire, one touches the tip and one touches the metal casing. And then you have a complete answer already. So your different answer may be such that I'm sure a different answer. The different answer could be negative going to positive. Alright, positive going to negative. Something like that. Okay? Alright, question 31B. What are the smallest and the largest number of bulbs that will make sure the number will lit up when one of the bulbs is blown? Okay, so the smallest number actually would be 0. Why so? Because if you look at the picture, so long I just blow up B2 or B4, the whole thing is no longer going to light up. Alright, so the smallest number that will be lit up once I blow off B2 and B4, nothing will light up anymore. It will be 0 bulbs remaining lit. So the answer is why? Because if B2 or B4 is blown, is fused, none, which is 0, of the bulbs can light up already. Alright, okay, what about the largest number? So this is resetting the picture. The largest number that will remain lit can actually go up to 3, not 4. Alright, now let's see how. If I fuse, example this, B3, this one can still light up, right? Because the electrical current can still flow. This one can still light up, and this one can still light up. You see the advantage of a parallel circuit, alright, is that one of it fuse, the other one can still light up. The rest is not affected because it is still a closed circuit. So the maximum number will be actually 3, not 4. So why so? Because if B1 or B3 fuses, the other 3 can still light up. Quite an interesting question, right? So testing you on how much you know about the properties of parallel and series. Okay? Okay, question 33. Gopal conducted an experiment in a dark room. This device, the device X over here, actually has got a drum that is made of plastic strips and metal strips. Okay, there's a light sensor here. You know that plastic strips, metal strips, which one is transparent, which one is not, right? Which one allows light to pass through, which one doesn't allow light to pass through. So what happens is that as the wooden rod is being turned, you know, like the musical box, you turn the wooden rod, the drum is going to rotate, and the light bulb will turn on and off, on and off, on and off, on and off. Right? It makes sense, right? Because plastic is a non-conductor, it's an insulator, whereas your metal is an insulator. Metal is a conductor, sorry. So he's going to measure the brightness using a light bulb. So obviously you know that if it doesn't light up because it's an insulator, the light will be shut off, right? You won't even have any amount of light detected. So question is, based on the graph, how many metal strips were there? Metal strips would mean that it is opaque, right? Metal strips would actually mean that it is, opaque, as well as it is a conductor of electricity. Okay, so if it is a conductor of electricity, it's going to have the lights lighted up. Okay, so if it is lighted up already, that means all this would be when the metal strips are rotated too. That's why it lighted up. Alright, now the answer is actually 4 and not 5, because for one complete round, it means that the last part here is actually going back to the first one. Do you get what I'm talking about? So for a complete turn, you actually go back to the original. So that means the last strip is actually the same as the first strip. So we don't count that as another strip, because your complete round means you will have returned back to the original position. So there's actually only a total of 4. Device X serves the same function as a certain part. So the device X is what? Device X is the picture, this thing, right? So you can actually switch on, switch off, switch on, switch off, because of the metal, plastic. So name one thing that is in an electrical circuit. Okay, now you have learned so many parts. You have learned about bulbs, you have learned that there's this thing called switches, wires, and so on. Alright, so the part that functions exactly like the device is what we call as a switch, right? So if you switch on to a particular mode, electricity cannot pass through. If you switch off, your lights is off. That's because you have an insulator or a space, an open circuit. So the switch is the one that represents or resembles the device. Okay, next page. Gopal then made some changes to his setup. He replaced all the plastic with metal. So now it is all going to be conductors. And he added one more battery. Now you're going to draw a line to show Gopal's result when he turned the wooden rod one complete round. So since there's no more plastic, it's going to light up continuously, right? Because this is a conductor of electricity. It's going to be throughout. And he added one more battery in, which means that now the brightness is going to increase, right? So your answers will be anything that remains constant and above 500. Okay, so if you have drawn a line that is straight and that's above the dotted line, you are already correct. And explain why. Okay, now you will need to explain for two parts. So these two parts have to be explained fully. You cannot miss out on one. So the first thing is because adding one more battery, what is the result? Increases electricity current. And when it increases electricity current, what is the result? Bulb gets brighter. So that's the result. So you have talked about the battery already. Alright, so hold on. Okay, I'll continue in the next. Okay, so we continue from the second half. You have explained about the battery, and we're going to now explain about how changing the plastic strips to metal strips will help. Okay, so why does having a metal strip make sure that the light, the brightness remains constant? Okay, so because it's a metal strip, it's a conductor of electricity. So it creates a, what is the keyword? Closed circuit for electricity to flow. Closed circuit for electricity to flow. So these are the keywords that needs to be in. Okay. Next. Question 33. Philip wanted to find out how the length of the wind light structure found on a fruit will affect the time taken to reach the ground. So these are the aim of the experiment. Using the same type of paper, fair test, he made 3 different models, and he's going to use a fan to drop them. So the time taken, that's for P, that's for Q, and that's for R. So it seems that the longer the length of the wing, it took longer for it to reach the ground. So explain the relationship cause and effect again. So the cause would be the longer the length of the wing, the more time taken for the model to reach the ground. Okay, so this is the cause and this is the effect. Alright, so let me just write down, this is the cause, this is the effect. Okay, so the cause must always start first, and the comparison words is there. Okay, now give a reason why using the same type of paper helps to make sure it is a fair test. Alright, now we go back to the aim. We want to find out if the length of the structure affects the time taken, right? So that is the only change variable. By keeping the type of paper the same, what happens is that you are trying to make sure the results is only affected due to the change variable, right? And not because of other variables. So in this case, we put it into words, it will be because so that the results is only affected. The keyword is only by the length of the wing and not other factors. Alright, so the idea is that because you only want to make sure that the result is affected by one change variable, not more than one change variable. It is only affected by the length. Based on the results of the experiment, suggest one advantage to have a long wing-like structure. Okay, so what happens when you have a long wing-like structure? You are able to, what do you think the keyword would be? Glide, float in the air. Alright, so the structure would allow fruits to glide further so that it will be further away from the parent plant. What is the reason why it needs to be further from the parent plant? Preventing overcrowding. So that's the end results. Alright, so if I look at what are the keywords that I will need, number 1, glide. Number 2, overcrowding. Okay, and let's see if the comparison words are better, further, and further. Okay, you glide further so that you are further away from the parent. So that's question 33. Question 34. The table below shows the melting point of substances P and Q. Based on the given information, would you be able to tell the substance at 100 degrees? So if we go by the number line again, 40 is here and it's already melted, right? So it is already a liquid state. Over here, it is at 60. For it to be at 100, it seems to be in a liquid state also. But the problem is, did they mention about the boiling point? Because if the boiling point happens to fall below 100, it won't be liquid anymore, right? It could be already a gaseous state. So would I be able to tell the state of substance at 100? The choice is no. Reason is, although it looks like they are both in liquid state, but what if their boiling point is less than 100? They will have already boiled at 100. They will have already become a gaseous state, right? So we won't be able to tell. Why? Because at 100 degrees Celsius, this P or Q or both can be at either liquid or already boiled. so we can't really tell. Alright, why? Because the boiling point is not known. So you notice this kind of question, every time it is given, you will always tell you 2 points, whether is it a freezing point, the boiling point, or the melting point with the boiling point. 2 points are always given to you, so you can know what state it is falling in between. Okay, so as the boiling point is not known. Alright, next question. John has a solid G that is made of substance P and Q, like that, combined together. So to separate the solid into 2, that means make them apart. Now they are joined together. He will need to heat solid G to a certain temperature. And what could this temperature be? Alright, now there's a lot of possible answers, so long your answer is between 41 degrees to 59 degrees, in between. Any one of the answer is correct. Now the reason why it has to fall between 41 to 59, okay, is because this happens to be when it is, for example, at 41. P will have already melted, but Q has not. So because the difference in state will allow you to separate them faster, right? For example, one is already in liquid, the other one is still a solid form. You can remove the liquid easily. If it's 42 also can, 43 also can, 59 also can. Why 59 can? Because it means that Q haven't melted yet. Q is melting at 60, right? At 59, P is melted, but Q haven't melted yet. So you can still separate them easily. One is a liquid, one is a solid state still. Alright, so that's why it must be between these 2 zones, 41 to 59. So the difference in the state helps you to separate them faster. So using the same heating method in part B, John could not separate H into the 2 substances P and Q. And what is the reason why? Alright, now there's only one reason, because of the states of matter has not changed yet. So P and Q is already melted. Alright, if you would want to use the melting point as a way to separate things, P will have melted already. But what happened is that Q has not. So it is still not a liquid state yet, it is still stuck together with H. That's why if you want to melt in between 41 to 59, you find that yes, P has melted, but Q haven't melted yet because Q is supposed to melt at 60. So Q is still a solid after all. It is still stuck together with solid H. That's why it cannot be. So it cannot be separated. Or if you want not to copy the question, it will be so Q is still a solid like H. That's a better answer because you don't copy the results. Remember, this is the result. You don't copy the results from the question. You have to think your own result because it's not melted, so it is still a solid, just like H. That's why it's not melted. Okay? Alright, question 35. Let's move on. Now, question 35 is something that you will have done an experiment before. So the amount of water droplets that's collected seems to be more in X than in Y, right? So there's 2 different setups. So I would already what comes to my mind, this is a comparison question. Okay, so there's lesser water droplets. Over here, you have more water droplets. Now the picture already shows you the result. Okay, but of course in the table here, it's also proven Y is collecting more water than X. Explain how water droplets will form. So this is the type of question where you need to talk about both evaporation and condensation. One of the few that can test you on both concepts. Alright, so we're going to start talking about the beginning first. This is about water. Remember, you have to talk about the location in the cup, gained heat. Alright, now in this case, because they didn't mention where is the heat source, so I cannot assume, so I will just have to leave it blank, no choice. Alright, and evaporated into water vapor. Next, what happens? The water vapor rises up to where? To the metal plate, right? To the metal plate and loses heat to it, which is the plate. So it condenses. This is the result already, forming water droplets. So I hope you're getting the hang of it, because this is a dictation that we have been doing in the past. Okay, part B. Based on the above experiment, what can you say about the temperature of the water in cup A and cup B at the beginning of the experiment? Alright, now the temperature has to be different. Why would I say that? Because given that they got the same volume of water, but how come A has lesser evaporation taking place? How come A has lesser water droplets formed? It's because there's lesser condensation, right? And it is because of lesser condensation. Why? Why is lesser condensation? Maybe because there were lesser evaporation. Alright, with lesser evaporation, what does that tell me about the temperature? You know that the higher the temperature, the greater the evaporation, right? So since there's water droplet being lesser, it means that condensation is lesser, evaporation is lesser. That means the temperature also must be lesser in A. Alright, so what can I say? I will say that A has a lower temperature. Why so? So I'm now going to focus on part A, because my answer is tilted around A, focused around A. Why A has a lower temperature? Why? Because it has, or rather A has, a lower rate of evaporation. So lesser condensation took place. How do I know lesser condensation took place? Because there's lesser water droplets. Okay? So I can conclude that A has a lower temperature. Okay, part C. Without changing the setup, how you can do to increase the amount of water collected in X. Without changing the setup, what can you do to make sure, so you have to have your beaker still there, your volume of water still there. To make sure that you increase the amount of water means you are trying to increase condensation, right? To do that, you must first make sure you increase evaporation, so that there will be more condensation, right? How do you increase evaporation? Few ways. Remember your temperature, remember your humidity. Alright, reduce humidity, increase your temperature, increase wind also can. Alright, and also you can, what can you do? Expose surface area. But in this case, you can't really do much to expose surface area, because the cup size is the same. So the only way, the few ways, would be either you place it in somewhere where it is windy, but actually you can't change the location also, right? So the only way is to increase the temperature. That will be the best way. Alright, okay, now we move on to the last question for today in this video, and it will be this one. Look at the plant below. Which parts are water carrying and which parts are food carrying tubes? Alright, now you know that all parts of the plant needs water, all parts of the plants needs food. So which one has all the water carrying and food carrying tubes? The leaves will have the water, stems will also have the water, roots of course, in order to absorb water it must have the water carrying tubes. What about food carrying tubes? Of course, leaves is the food factory, it must have the tube. And the stem needs the food also, the roots also needs the food. Okay, so all parts of the plant will have water and food carrying tubes. So that concludes the first half of our open-ended section. So we'll see you the next day for the second half of the open-ended. Goodbye.